Hello and welcome back to our last topic of the year. You've almost made it. We're almost through. We're going to start this unit off with a little lecture about taxonomy. So let's dive right in. You may have heard of taxonomy, you may have heard of classification before, but let's set some ground rules on what our definitions are going to be for these two terms. So when we are talking about classification, we're going to be talking about how we group objects, information, organisms specifically, that's what we're going to focus on in biology, based on similarities and evolutionary history, so how they have evolved over the years. Taxonomy is just this idea of grouping and naming organisms, any sort of living thing. So you can classify anything, right? You could classify the types of chairs. But taxonomy is specifically the classification of living things. So it's just like a bit more specific. So who can you thank for having to learn all of this? You can thank Carl Linnaeus. Carl Linnaeus is this guy, this old dude right here. He developed the present method of classification. Of course, there have been changes, there have been tweaks over the years to make it a little bit more accurate and a little bit better, a better way to classify organisms as we have discovered more since his time. He specifically classified organisms by their physical and structural appearances, so how they look. Now, you're probably thinking, yeah, that makes sense. I mean, most birds look the same, but you wouldn't say that a penguin who can't fly is the same as a bluebird that can fly. So although they both have wings, which is a structural appearance, a physical attribute, they are not the same species. So it was a great way to start this idea of classifying organisms, but of course, as we have learned more, as we have grown in our understanding of how organisms evolve, our ideas of DNA, we have been able to really streamline the process of classifying organisms to be way more accurate and just a much better system. But he started it all, and we have to give credit where credit is due. When we are talking about organisms, we use their scientific name. And I know that you guys are aware of this because I've brought it up to you many times that you have to use an organism's scientific name when you're referring to them. Well, the idea of using a scientific name is actually called binomial nomenclature. Bi meaning two, nomial meaning name, so a two-name system, right? Nomenclature is the way that we would write a name. So two-name system. Which is literally the first bullet point, right? They're named using a two-word system. The first word being the genus and the second word being the species. The genus is always spelt with a capital letter, and the species is always a lowercase letter. To be precise in the way that you write and talk about scientific names, they are either italicized if they are typed on a screen, or they are underlined if they're handwritten. And scientific names are written in Latin, which is a dead language, which is why when you're looking at scientific names, you're probably like, what are these words? I've never seen these words before. And that's because it's in Latin. We don't use that. We don't speak Latin anymore, but it's used in tons of different ways, right? It's used in, obviously, classification, right? But it's also used in like the medical world because when all of these things were being discovered for the first time, Latin was a language that was used by academics. So everything got written down in Latin, everything proceeded to continuously be spoken and written in Latin, and it just never changed. We've never brought that into like English or another language. We use Latin. It's the same across every country. It's a common way to refer to certain things where everybody in the entire world would be able to understand what you're saying. Okay, so we use Latin even though it's a dead language because that's how it started. An example of a scientific name is Canis lupus, right? That means wolf, right? Homo sapiens means humans. I'm sure you guys remember in your honors project the different scientific names that you've used for the organisms that you were testing, but these are just some examples. So the system of classification has 7 taxa, right? We call them taxa as like almost like part of taxonomy, right? It's a category within taxonomy. So Linnaeus' system had 7 taxa, or 7 categories, but now that we've evolved a little bit more, right? We've learned more about how species are really classified. We actually have 8 taxa now. So genus and species have always been there, right? That's what you use to make your scientific name, right? This would be like Canis, species would be Lupus, okay? And as you go back, you get more broad, right? More organisms are within a family, more organisms than that are in an order, etc., etc. Linnaeus' system stopped at kingdom, but modern day classification includes domain as well. And we're going to talk about the differences between domains and kingdoms in our next set of notes. So, going down, domain is the most broad. Most broad category, right? It has the most amount of organisms within it, and species is the most specific taxa. It has the least amount, usually one organism within it. You can actually have a subspecies, which is even more specific, but we're not going to cover that. You just need to know domain through species. And if you thought I wasn't going to tell you exactly, like give you an example and go through all of it, you were wrong. So when we're talking about the taxa, the specific taxa, right, we have domain, most broad, then kingdom, phylum, class, order, family, genus, and species, okay? Most broad to most specific. A mnemonic device, which should help you be able to remember the order of the taxa, is did King Philip come over for great spaghetti, right? Did starts with a D, so does domain, right? King, kingdom, Philip, phylum, right? It all matches up so that there's an easy way for you to remember, okay? So this is a great way to remember the order of the taxa from the most broad to the most specific. You will have to know this. You absolutely will have to know the order of the taxa, so please write this down. And I wanted to give you an example just so that you could see, exactly how we would classify a specific organism. In this case, we're going to talk about humans. So the domain in this case is eukarya, and we've talked about eukaryotes before, and that's exactly what this means. So eukarya is just any organism whose cells have a nucleus. Very, very broad. Pretty much everything except bacteria fall under this domain. So that's a lot of organisms. So then we are going to get even more specific in the kingdom, and we're going to talk about animalia. So now we're talking about animals, right? That's what that word means. So now we've eliminated, plants, fungi, protists, all of that. Then the phylum is chordata. This means that they have a spinal cord, right? You have like a spine on your back, right? So now we've eliminated any organism that does not have a spinal cord. As we continue down, right, mammalia, primate, hominidae, so all of these are just getting more and more specific as we go, and finally we get to the genus and species. Our genus and species is Homo sapiens. That's the classification and the scientific name for humans. Notice how it's written in italics, because when you are typing a genus and species, it has to be in italics, right? Genus is capitalized, species is lowercase. Still following the rules that are present for writing your scientific name. And last but not least, relationships between organisms. So when you are talking about relationships between organisms, the more taxa that organisms have in common, the more closely related they are, which probably makes sense. The less classification that organisms have in common, the more distantly related they are, or the less related they are. So if we're looking at these, right, notice that I don't have all the taxa. I just have kingdom, phylum, genus, and species. So we eliminated 4 of the 8 total taxa. And if we're looking at all 4 of these organisms, if we start at kingdom, we have 1 plant and 3 animals. So we already know that organism A is probably the most distantly related to all of the other organisms. And so if we move down to phylum, okay, they're all chordata, so it doesn't really matter. They're still pretty similar. If we move down to genus, we have 2 Canis and 1 Homo, so that means that organism D is less related than organisms B and C. And if we move down to species, you'll notice that they're different because most species are different from each other. So we have Canis familiaris, which is like a dog, like a regular like household dog, and then Canis lupus, which is a wolf. Now we know that they're related, but they are not the same organism, so they have a different classification. They are the most closely related because they have the most taxa in common with each other, and then you can say that organism D is the next closely related because it has 2 out of 4 of the taxa that we looked at in common. All right, great job, and I will see you next time.